Hello, this is Pete Cacciopi. I'm Chief Scientist Optolytics, and this is video number 3 in the tutorial series for the Gurobi webinar on machine learning and optimization. In video number 2, we used an off-the-shelf application to perform cross-fold validation on a historical data table and to determine the most appropriate algorithm with the most appropriate parameters for this data set. As a result of tutorial video number 2, we created this report with which we determined that the big random forest is the most appropriate algorithm for this data set. The next step is to do the equivalent of creating this fitted variable here at cell number 15 in the notebook. So as you recall in the webinar, I talked about how in a production environment, you would perform your training step and then serialize or archive the results of that training step so that predictions could be made in the future independently of the due diligence work that determined the most appropriate algorithm. So in order to do that here with our app, we first need to populate the random forest fit table with the big random forest. So that's easy to do. Recall that this option has 100 estimators. And then now that we've set that up, we just need to launch our solve. And as the result of that solve ran successfully, and we created this predictor object. So in order to archive that predictor object, in this platform, archiving a predictor object is the same as turning the predictor object into its own engine. That's what the publish step is for. Perhaps more accurate to say it's just you turn the predictor object into its own little application. So the application that we're creating here is one that will predict the soda sales. So let's use that name. And let's validate that we've created that application. We can go to the App Store. And if you look under Publish Predictor, there it is, Predict Soda Sales. See, it's the same little shape in the Identicon. So now let's make sure it runs. To do that, we'll upload a file. In this case, we're uploading the Super Bowl promotion data file. Again, this is in the ML Soda promotion directory that I showed you how to create in video number 1. And the solver type or the application type, again, that same Identicon for predicting soda sales. In this case, we've uploaded 36 records for the Super Bowl promotion data. And you notice, of course, that the sales column is missing because that's the dependent column. Here are all the independent columns with which we can predict sales. And again, there's no need to force the user to dummy up the columns. The data is presented to the user in the natural format where there's a mix of of categorical and continuous columns. Now, solving here is the equivalent of just making that prediction of what is the predicted demand for soda for each of those price points. And there were 36 data records. So you see in our reports, we've created 36 predictions. Here are the predicted column values here. Now, if you noticed in video number 2, I pointed out how you could identify your predictions using an observation column. In the absence of an observation column, the observation column data is just numbered sequentially from 0. Thanks for your attention. And that concludes this video on creating a predictor object and archiving it as an application engine.